But then I was also a little reluctant because you don't ask questions, you don't show your faces. See, normally I take classes. I've been teaching for a long time, and I'm used to, seeing faces and talking to the students and other professionals. So that was one thing which was keeping me away from this session. But still, I wanted to interact with you and giving you, you know, share some of the knowledge which I have with you. So I thought, okay, I'll take one session, um, one more session. So this session is actually on codes, basically Indian standard codes. I am sure you have very good, learning sessions in the past few months, and I'm sure you all are benefited from that also. If you have any questions when I'm taking the class, during the class or after the session, you can definitely ask me the questions. I'll be happy to explain. And if I'm not able to explain anything, definitely I can refer and come back and explain it to you. Okay, shall we start? I hope this is an okay for me. I hope you are able to see my screen.
Yes, ma'am.
Yeah, thank you. Um, I just want to ask some questions also in between, if it is okay with you all, at least to so that I am clear about what you know about codes. Okay, so basically, I'll be talking about Indian standard codes, IS codes, and some important clauses in some of the codes, and how you have to interpret those clauses so that it can be used in your design and execution of any job. Okay, so this codes, I hope you have covered in some of your courses. So which all codes you know and you have referred so far? Anyone?
Yes, ma'am.
Yeah,
We
yes,
have
Sajal.
referred IS 456
Yes, IS 456,
2000,
uh,
then SP 23.
SP 23, IS 456, and I'm sure you might have seen IS 875 also. No, because when you are referring IS 456, IS 875 also comes in the picture. And that means that IS 456 you referred in your reinforced concrete design course, right? Yes. So this is in general, you referred some of the important codes while designing and some other codes while doing the execution of any work. So both the codes are different, but they are interrelated also. Okay. So this is what I'm going to talk about today. Referring codes in civil engineering, how we have to refer, how we have to interpret some of the clauses. So definitely it is a vast area. You have to have at least 3-4 courses to complete this. So in one day, in 1 hour, I may not be able to give you, um, more than some clauses in one code. Okay, so just a glimpse on how to refer a code and how to interpret certain clauses in the code. And based on this, you can do the other codes and codal clauses. So this is how I planned this particular session. Introduction, functions of codes, benefits of using codes, and most referred codes and handbooks in India in civil engineering. and interpreting the clauses in codes. And one case study I have taken, and what was wrong with that particular project, and how, because of that, failure of one of the projects, what they have learned and how they have accommodated the lessons learned from that particular failure in the code. Then the conclusion. Now, why you want a standard code? Okay, so this is because we need a guidance while designing any structure, or while executing the construction of any structure. You need some guidance. You cannot just blindly go and do a design. Okay, even though you have some courses done, you know how to find out the bending moment and bending moment diagram. But while designing a beam, you should have some guidance of how to um, proportion the beam in such a way that it will be stable and it will be strong. So for this, you need some guidance. So that is one reason for this code um, reference. And second is reduce risks. So if you follow certain rules and regulations pertaining to the design and civil engineering, definitely you can reduce the risks. What are the risks? The failure of the particular member, or failure of the whole structure, or failure of the construction at construction of some of the, while constructing a member or a building. So if there is a failure happens, you can prevent that. So these are reducing the, you can reduce the risks. And another important thing is conform to acceptance criteria. So if you have to accept certain um, criteria, that should conform to certain rules. So for example, if you are designing a column, okay, the column size should be this, the minimum reinforcement should be there. I'm talking about reinforced concrete members, basically. So it should have a minimum percentage of reinforcement. And whether the column is a short column or a long column, for all these things you need some guidance. Okay, so those guidance and those things which will make anyone to accept that particular member. So when it is conforming to certain rules and regulations or certain clauses given in the code, then we can accept that. Okay, then consistency, which is very important. So I am designing a column and you are designing a column. The columns should be for the same load and same exposure condition, and for the same type of building. Then when the construction is being done in the similar place in the sense, when you are considering a place, whether the earthquake prone area, what is the zone of earthquake, it is zone 3 or zone 4. So if the zone is 3, when I am designing that particular column for zone 3, that particular design should be consistent with some other design some other person is doing for the same conditions. So that will give you a consistent design. Okay, then ensure the quality of work. So whether it is in design or in construction or execution, or the decision on the type of material. Okay, so there should be some rules or some criteria based on which you can accept it. So that acceptance criteria is based on basically the quality. So that these codes give you certain criteria, acceptance criteria for this. So that is how it is ensuring the quality of work, whether it is in design or execution of the job. And it also safeguards the public, in the sense, if it is not designed safely, the safety is a main criteria. So whoever is using, especially in the case of a public building, whether it is infrastructure or a hospital or a mall, where the public is going, and it is the question of their safety. So that safety is safeguarded when you are designing based on a standard code. Then legal protection. What is legal protection? Suppose you are designing something and some failure happens. Okay. And you have designed based on certain criteria and there is a dispute saying that, okay, this design is not done as per the norms. Then you have a design criteria based on code and that will give you a protection, legal protection. You can always argue based on the codal provisions. Okay, so that will give the designer or a construction engineer a legal protection in case of dispute. Okay, so this is why you need a standard code. So this code is accepted by the design engineers in civil engineering or the construction engineers. So all engineers in the civil engineering field. Okay, so that is why we need a standard code. Now, coming to Indian Standard Code, while doing or making this code, we have certain bodies and they only formulate these codes. So we have an apex body which is owning all these codes, which is BIS. BIS is Bureau of Indian Standards. And under that, there is a committee pertaining to that particular code. So we have codes for design, we have codes for construction, we have codes for material quality. So all these codes will have separate committee pertaining to that particular code and and then there is a civil engineering division council. So all these members will be the experts from different areas. There may be from members from the research area, there may be members from the industry, there may be members from the teaching community. So all these, there will be representation from all these fields in these committees. So they will review what is given and then they will formulate the clauses and then the apex body, which is BIS, they will um, release these codes. They are going to release the codes. Okay. So that is why we always say you have to get the BIS, Bureau of Indian Standards. From there only you should get the codes. Now, all the codes will be revised from time to time. Of course, in India, the revision, comes, after a long gap only. But in India also, there are amendments in some of the clauses. So if you can see any code, you can see some amendments pertaining to any code, especially IS 456, IS 1893, IS 800. These codes we use quite often. So regularly there will be feedback coming from the design industry, from the construction industry, and from the research area. There will be regular feedback. Based on that feedback, they review the clauses and they make some amendments. So these are coming as amendments pertaining to certain clauses only. Okay. Now, all standards are subjected to revision. Why? Because they need to have a continuous improvement based on the feedback and research findings. And you always should refer the latest revisions or editions of the standards. This is also very important. So when you say IS 456, IS 456 1978 is there, IS 456 2000 is there. So always you refer the latest revision and the latest edition. Why the latest edition? Because there will be some amendments. Okay, that is why it is important to refer the latest editions of the latest revision. Okay. Now, how the code is helping us? This is same as what I explained to you before. It gives you the guidelines for material, design, and execution. So the material properties, which is the code you refer for material? Anyone? What are the materials? Mainly, I can say that we are, let us say, for concrete. So for concrete, what are the materials we use?
Aggregates,
Aggregate,
cement,
cement, water.
water.
So yeah, all these materials are there. So for cement, there are codes. Cement, there are different grades. That is, which are the grades? Any idea? grade 33, 43, 53. Those are the
33, 40.
grades. Yeah. So each cement grade will have different codes. Okay. So that code you have to refer. And for aggregate, fine and coarse aggregate, we have to refer another code. Which code? Any idea? IS 383 we refer for aggregate. And for concrete, which code we refer? One is IS 456 itself. Okay, in IS 456, it gives you the quality of concrete and how to do the mixed design. You can refer another code. You remember? Anyone remember that code? IS 10262.
SP. Uh,
Yeah, SP is the handbook. Okay, and code is different. SP is developed, or SP is given based on the clauses given in a particular IS code. So any SP you take, it is a handbook, okay, explanatory handbook for a particular code. So for IS 456, there was an explanatory handbook which was SP 24, but that is withdrawn now. Okay, that you cannot refer now. From it is withdrawn by the Bureau of Indian Standards. So certain codes are withdrawn based on certain criteria, and certain new codes are introduced. That also I'll tell you, which are some of the codes which you should refer the latest editions and the latest codes also. So it gives you the guidelines for material and design. For design, for RCC design, the what you call the Bible of RCC design, you can say, is IS 456. You refer IS 456, you will get almost everything for RCC design. And then there is an explanatory handbook for that, which is, I said, SP24, which is withdrawn. Still, if it is available, you can refer for some of the clauses. Okay. But IS 456 2000 is giving you some of the new materials in cement, which is fly ash cement, which is added. That is PPC. Okay. PPC also is included in IS 456. That is why SP24 is withdrawn, because it was not giving you any idea about those new materials in construction, based on PPC and other types of cements. It also specifies the standards for the design of all types of structures. So even if it is a tall chimney or a water tank, or it is a concrete building, okay, steel building. So it gives you the standards for the design. And it provides guidelines for safety, strength, health, serviceability, and other amenities. So what do you mean by amenities? Whatever is required in a building. Okay, like serviceability means what? You should be able to use it for the purpose for which it is designed. If it is a school building, the rooms should be big enough, and there should be enough headroom for all the pupil or all the students to sit. So that much space should be there. So that is given in which code, NBC, National Building Code. Okay. So there is a condition for that. Then some of the codes give you how to give the amenities. So what is the space required for a walkway, or the connectivity, or toilets, such amenities, how you have to design for that. Those things are also given in some of the codes. Now, how a code is formulated. So it is just out of the blue. Nobody is preparing a code. It is in response to review of a prior failure. So based on something, when you are constructing something, there is a failure. Then you study why this failure happened. So based on that review, you make a code. That will be one part of the code. Then from feedback from practicing engineers. So when you are doing the design or construction, then you get some idea about the failure or the minimum things you should give. So they give a feedback. This should be constructed. If it is on a soft soil, there should be a pile foundation. And if the soil is very soft, then you cannot have a end bearing. You have to depend on the friction. So these are the feedback you get from the practicing engineers, and that feedback, from that feedback, people do research work. Okay, so how much length you have to give. So that is based on the experimental work. So it is a combined effect of all these things you make a code. So research findings are there. Then to address the experienced inadequacies in the design and execution. So when you are doing some execution of a job, you will find that, okay, I am not able to reach this part of the building because there is, you know, that beam is too deep, or the column beam connection is very heavy. So what kind of things we can do it there? Okay, for ductility, how, what exactly you should do at the beam column junction, and when there is a congestion of reinforcement, how you can overcome that. These are all the practical things which you get from a practicing engineer or an in construction engineer. So then based on that, you do some beam column joint experiments and see how you can rectify those problems. So these are the things which you get, and these are the things you take the feedback, and then you analyze it, and then you will come to a conclusion based on all this feedback, and you then make a or formulate a code. So we are all responsible for formulating this code. So as a student, you should also look into these details, okay, and think about it and see what all things you can do to improve the design and construction. Okay, so now only if you start thinking about it, you will be able to look into those details while doing a design or in the field as a construction engineer. And this is also very important. Always remember, no code can eliminate mistakes and risks. So it's because you referred a code, you cannot say there will not be any mistake. Mistake is um, humanly made. You know, humans, like an engineer, can make mistakes. But that is why we say that whenever you are designing something, there should be a second check. This I explained to you in the last session when I was taking that. So always see that whenever you are designing that, someone else is checking it, so that the mistakes are lessened. The number of mistakes are lessened. Okay, so it is very important, and people can make mistakes. That is, to err is human, as we say. So we cannot avoid that, but we can definitely avoid blunders. That is for sure. Okay, and risks are there. You have to take some risks, but you can reduce the risk. That is while referring the codes. Now, what are the benefits of using these codes? You can you can get the quality, as I explained to you before, consistency, improved competitiveness and legal protection, safety, better decision making, and facilitation of trade. So these are the things which you can get while using the codes. Now, these are the most referred IS codes and handbooks in civil engineering. Most referred. This is not an exhaustive list, but most important codes which we refer. IS 456. These are the latest revisions and additions you have to refer. IS 875, which has 5 parts. IS 800, 1893. 1893 is again revised to have 6 parts. I'll explain to you that also. IS 13920, which is used for what? Any idea? Have you heard of IS 13920? This was ductility. IS 383, I told you, for material aggregates. IS 10262 for it is for mix design of concrete, and IS 250 is for detailing. Okay, so detailing, that is bar bending schedule. So when you are designing an RCC structure, you have the reinforcement and how much length is to be cut, and what is the development length, how much anchorage, So those things are explained in IS 2502, how to number it, how to calculate the bent length. All these things are given in IS 2502. So then there are some handbooks, SP23, SP24. SP24 is not there, it is withdrawn. SP34. So these are some of the most referred code. This is, as I told you, is not an exhaustive list. Now comes to the most important part, which is interpreting the clauses given in the code. Okay, so what is the importance of interpreting the clauses given? Each clause, if you see the languages given in the code, it is like the law language. It is very difficult to understand. So some of the clauses, even if you read 4 or 5 times, you will not be able to understand what they are meaning. That is why an explanatory handbook is given. And sometimes even that explanatory handbook may not be available. And even if it is available, it will be very difficult for you to interpret. Okay. So in such cases, what you will do when you are not able to interpret it? What is the suggestion? What can you do when you are not able to understand some clause given in the code? Have you gone through IS 456? Some of the clauses? Yes.
Yes, ma'am.
Yes. So any of the clause which you were not able to understand, or you were able to follow all the clauses given in that? Some of the
No,
clauses
ma'am, it was difficult.
it was difficult. So when I used to take design classes, what I used to do was I take the clause and I ask the students to read some clauses and then we discuss in the class. So that it is each student, some of the all, as everybody will not answer, everybody will not take part in the discussion also, but some of them definitely they give their views. So then there is a discussion. This, if we can do it in your class also, it will be good, so that you will know how to interpret it. If the teacher is there, definitely they can explain to you. So some of the clauses are very difficult to understand and it is confusing also. Okay, that is why. So when you are not able to understand some of the clauses, what you can do is the same thing, you can have a peer discussion. Okay, when if you are working in a company as a design engineer, you can have discussion among your peers or you can ask your seniors. Okay, and nowadays definitely the internet, so many things are available, but you should definitely refer to the right site, because all explanations are not correct, which are given in the internet. So remember this also. Okay, always important to refer the right site and refer to the right people, so that you are not confused more and it will be clear to you also. So clauses will contain more than what it says. That is one thing. Okay. So it may give one sentence, but there will be some meaning in each of that sentences. It is important to read the notes given after the clauses or tables, if any. So more than the clause, if a note is given, definitely you should read that note. It's for sure. Okay. And it ensures safety and economy. It avoids rework. It ensures quality of work. It safeguards the public and it gives you legal protection. All these things are repeating only, but these are some of the positive sides of rightly interpreting the clauses. Okay. Now I'll take IS 456 and I'll take some of the clauses given in IS 456 and will tell you how to interpret it. Okay. Based on this, you can also do your own interpretation. Now, IS 456 is the code for plain and reinforced concrete, the code of practice. See, that itself give you an idea about what is that code giving you. It is the code of practice. It is reaffirmed in 2011, 2016, and in 2021 also. Okay, there are some amendments. So that is why 2021 reaffirmed code only you should use. IS 456 2000 will have these editions, but you should refer the edition which is 2021 reaffirmed. Okay, it has 5 parts. One is the general part, the materials, workmanship, and inspection and testing, which is about the material, the workmanship, and how you have to test it. Okay, how you have to inspect it, how you when you have to remove the scaffolding, the formwork. These things are given in the in this section 2. And what are the general design consideration, which is given in section 3, and special design requirement for structural members and systems, which is given in section 4, and limit state structural design. That is why IS 456 was, reissued in 2000. They have withdrawn IS 456 1984 and reissued IS 456 2000 to include the limit state design, okay, completely, and include some of the latest materials, especially the cement, PPC, etc. Okay. Now, when we take this code, what you should do first is you should actually read the first part, which is the forward. Okay, this is the forward. See, you can see that this, it is given here, this Indian standard, which is the fourth revision, was adopted by the Bureau of Indian Standard, BIS, I told you, after the draft finalized by the Cement and Concrete Section Committee. I told you there will be a committee for this particular one, the committee, Cement and Concrete Sectional Committee, and it has been approved by the Civil Engineering Division Council. Okay, so the members of this council will be given at the end of the code. So their names or their designation, everything will be given at the end of the code. And then this is the fourth revision of the standard. This revision was taken up with a view to keeping abreast with a rapid development in the field of concrete technology and to bring in further modification or improvements in the light of experience gained while using the earlier version of the standard. So you get so much experience while using it. And of course, there will be research done. And based on all these things only, it is revised. And another interesting thing which you should read in this or understand also is in this code, it has been assumed that the design of plain and reinforced cement concrete work is entrusted to a qualified engineer. So it is just not any engineer, a qualified engineer. Now, any graduate is not a qualified engineer. You know that very well. Okay. So it should be a qualified engineer, and that the execution of the cement concrete work is carried out under the direction of a qualified and experienced supervisor. That is also very important. They assume this is what is happening. Based on that only, they are formulating this code. What does it mean? It means that if it is a qualified engineer, whenever they are reading the clauses, they will understand it. And if they don't understand, they will definitely discuss with their peers and a senior person. Okay, they will not just blindly follow it. That is the meaning of that. Another interesting thing about this code is in the formulation of this standard, assistance has been derived from the following publications. So they have referred the British standards, the ACI standards, and even DIN. DIN means from German standard. Okay, they referred all these standards and then they formulated so that it is conducive to our Indian condition. So that is how this code is formulated. Okay. Now coming to some of the clauses in this code, it says that the combination of loads, this is 19.7 clause, it says the combination of loads shall be as given in IS 875 part 5. Okay, so this particular clause when you refer, you should refer IS 875. You should not go to the particular clause where it gives you the partial safety factors. It is not that. It is, this talks about the combination of loads. Now, what is a combination of loads? Now, if you see the combination of loads, this is IAS 75 part 5, special loads and load combinations. You can see that it gives you the load combinations. Now, the load combinations are, these are the load combinations. Now, this is again, it is not exhaustive. There are other combinations also. Okay. But these are the minimum combinations you should do while doing a design. So, dead load plus imposed load, dead load plus wind load, earthquake load. So temperature loads, these are the combinations you should do. Okay. In addition to that, this is what it says in the clause. But below this, they are giving some notes. That is why I said these notes are very important. So the clause says these are the load combinations you do. So blindly, we cannot follow this. There are some notes given in this. So these notes you have to read. What it says, the relevant design code shall be followed for permissible stresses when the structure is designed by working stress method. Okay, when you are doing the working stress method, you have to refer that code, and for partial safety factors when the structure is designed by limit state design method. So that is for each of the above combination, whatever combination they are giving here, either you should have a partial safety factor if you are doing the limit state design, or you should have an allowable stress if you are doing a working stress method. Is that clear? So partial safety factor you are using while doing the limit state design only. Then one more thing they are saying is, whenever imposed load is the live load. Live load, they have changed it into imposed load. Whenever imposed load is combined with earthquake load, the appropriate part of imposed load as specified in IS 1893 should be used both for evaluating earthquake effect and for combined load effects used in such combinations. What does it mean? Did you understand anything? It is very confusing, isn't it? So what it says is, when you are doing the combination of dead load and imposed load with earthquake load, dead load as it is, you cannot do anything. It is existing always. So when you are combining with imposed loads, what you have to do is, the appropriate part of imposed load as specified in IS 1893, 1984 should be used for evaluating earthquake effect and for combined load effects used in such combinations. So when you are designing for earthquake, how it is affecting any building or any structure, the earthquake? Any idea? How the load, what will happen to the building? So earthquake, how it is coming? It is like a wave. Okay. It is coming, wave is coming or passing through the earth, isn't it? On soil only. So when the waves are moving through the soil, what will happen? When it is moving under the building, there will be a wave formation under the building. Because of that, the building will start vibrating. Okay. So what will happen when it is vibrating? It will sway. Can you imagine that? Okay. When something is vibrating, it will try to sway. So in that sway, what will happen? Why there is a sway? Because it is just like any lateral load is acting, horizontal load is acting on the structure. So earthquake means there will be horizontal loads acting on the structure. That is the meaning of that, like a wind load. When wind is acting, what will happen? It will sway, or there is a horizontal load acting on the structure. Fine. So when you are doing that, what the code says is you have to take the appropriate imposed load. So what it is saying, it is given in this. This is the earthquake load. So it says that for various loading cases, the horizontal earthquake force shall be calculated for the full dead load. Dead load, there is no change. And the percentage of live load as given below. This is IS 1893. It says in clause 4.1. When the load is up to 300 kg per meter square, you need to take only 25% of the live load. So when you are doing the live load dead load combination here, when you are doing the dead load plus IL plus earthquake load here in this combination, what percentage of in IL you have to take for the earthquake load calculation? If it is 300 kg per meter square, then or 3 kilonewton per meter square, then you need to take only 25%. Okay, this is how you have to interpret that. And if it is above 300 or above 3 kilonewton per meter square, you need to take 50%. Okay, this 1893, 1984 says, and the when it is divided into different parts, this 1893 I told you is divided into 6 parts now. Part 1, general provisions of and building, liquid retaining structures, bridges and retaining walls, industrial structures, dams and embankment, and there is IS 1893 part 6, which is base isolated buildings. That is recently, they have 2022 only they released it. Okay, so we are talking about this general provisions and buildings. There also they say the same thing in the latest revision, that what is the percentage of load you have to take in imposed load. IL is 25% up to 3 kilonewton per meter square, and above 3 kilonewton per meter square you need to take 50. Okay, so I know it is a little confusing, but I want to introduce this to you. These things exist. You may not understand fully, but at least you will know that these things are there. Okay. Now, the code also says reduced imposed load specified in part 2 of this standard. This is again 875 part 5. Okay. It says of this standard for the design of supporting structure should not be applied in combination with earthquake. So they talk about a reduction in imposed load while designing the supporting structure. What is the supporting structure of a floor? This imposed load comes where? Anybody? Live load comes on where? In any building?
On the floor.
On the floor. Excellent. On the floor. Okay. So on the floor only coming. So supporting on the floor, so how the floor is supported finally by the columns. Okay. So that is what it says. When you are designing the supporting structure, this code says there is a reduction in the imposed load. What is a reduction? I will explain it to you. This is IS 875 part 2. When you are designing the supporting structure, okay, there is an example. I'll tell you this. So first I'll just see this. So when the number of floors are more than 10, up to 4, you can reduce from 10%, 20%, 30%, and 5 to 10, you can reduce 40%. These are the imposed loads. And over 10 floors, you can reduce up to 50%. So this is how it is done. You can see that this is the roof. Okay. In the roof, it is only one floor when you are designing this column. So you cannot reduce anything. If the load is coming is 30, you have to take 30 for designing this part of the column. Is that clear? There is no reduction. Okay. When you come to this column, that is the second, there are 2 floors here, more than one. So when you are designing this column, total of 30 plus 40, then you have to deduct 10%. That is what code says. Okay. When 2 floors are there, reduce by 10%. When there are 3 floors, you reduce by 20%. When there are 4 floors, above that including 30%, 5 floors you reduce by 40%, and more than that, up to 10 you reduce only 40%. Okay, this you can see. And more than 10 you can reduce by 50%. That is what the code says. Is that clear? So this is not for lateral load calculation. This is for designing these columns, supporting columns. So if you are designing this column, the imposed load parts, you need to take only 50%. I hope it is clear. But when you are calculating the earthquake load, you cannot reduce this. Is that clear? Okay. I hope it is clear. And one more, this is also very complicated. I don't know whether I should explain it to you. If you want me to explain, I'll explain it to you. The code says, when the floor is designed for an imposed load of 5 kilonewton per meter square or more, if the live load is more than 5 kilonewton per meter square, the reduction shown here, okay, may be taken provided that the loading assumed is not less than it would have been if all the floors had been designed for 5 kilonewton per meter square with no reduction. You want me to explain this? I'll explain. Otherwise, I'll leave it. It's a little confusing, but if you can understand it, anybody understood this? Okay, I hope I understand. Now I understood you don't want me to explain that, so I leave it. Fine. So this, at least this you should understand, that while designing the supporting structure is the column, foundation, okay, and piles. All these things when you design, this should be the way you should take the loads, the imposed loads. This is not dead load. This is the imposed load, okay, or the live load. Fine. Now coming back to our IS 456, the partial safety factors. The partial safety factor for loads is given in table 18. So these are the partial safety factor. This we use only in limit state of collapse when you are designed by limit state. So these are the factors or the load factors you have to take for the design loads. So you have to multiply dead load and imposed load when you are taking dead load plus IL on 0.5. When you are taking dead load plus wind load again on 0.5, okay. And when you are taking a combination of IL and WL, along with WL, you have to take 1.2, okay. Code also says you multiply the dead load by 0.9 when you are checking the stability of the structure. Otherwise, don't reduce it. Is that clear? So don't understand that when you are having a combination with wind load and imposed load, you have to reduce the dead load. It does not mean that. 0.9 you have to use when you are using or when you are checking the building against stability. So it explains here this value is to be considered when stability against overturning or stress reversal is critical. Then you reduce the dead load. Otherwise, you have to use 1.2. And code also says EL, you use earthquake load in place of WL when earthquake load is coming. So both earthquake load and wind load will not come at a time together. That is the assumption we make. So there is no combination of dead load plus IL plus WL plus EL. There is no combination. The combination is dead load plus IL plus wind load or earthquake load. Okay. Now, this is the how you are analyzing it. Okay. All structures may be analyzed by the linear elastic theory to calculate the internal actions produced by design loads. So how you are analyzing your beams and columns or the frames? Anybody? Are you doing the plastic analysis to find out the bending moment, or are you doing the elastic analysis? Hello, only Sajna is answering. Anyone else? How you see this? I don't know. Yes. How many of you are there? Nandana, how do you analyze it? To find out the bending moment, maximum bending moment for design, is it an elastic analysis or plastic analysis? Have you studied plastic analysis, Sajna?
Yes, ma'am.
Yeah. So, what kind of analysis? Nandana is there. Please unmute. Nandana, is she there or?
Yes,
Nandana?
ma'am.
Yeah. What analysis do you do to find out the maximum bending moment diagram?
Elastic.
Elastic analysis. Excellent. Okay. You do the elastic analysis, right? So that is what the code says. Do the elastic analysis. And all structures may be analyzed by the linear. That is, even if you are doing limit state design, the analysis is elastic analysis. Okay. Remember this. Okay. So when you are doing the elastic analysis, the characteristic strength means the value of this is for the limit state design. The term characteristic strength means that value of the strength of the material below which not more than 5%. Do you know that? What is the meaning of this? The term characteristic load means the value of load which has 95% probability of not being exceeded during the life of the structure. Do you want me to explain? I hope this is understood. Okay. Here also the method of analysis is as in 22, which means you are doing the elastic analysis. But the code says the material strength to be assumed shall be characteristic value in the determination of elastic properties of members, irrespective of the limit state being considered. Okay. So what does it mean? What is the stress value we consider for concrete, for example? We divide it with a material constant. Have you heard of material constant? No. What is a material constant for concrete and what is a material constant for steel reinforcement? Pradul, can you unmute? Are you there, Pradul?
Yes.
Yeah. What is the material constant for concrete?
I
1.5.
don't know.
What is
Yeah.
the material constant for steel reinforcement?
Mm, yeah,
Right.
okay.
Yeah. 1.15. You remember? See, when you divide by 1.15 only, you get 0.87. You know 0.87 Fy, right? You take 0.87 Fy for the stress value for reinforcement and 0.67 FCK for the stress value of concrete. How you are getting that? It is from this only. Okay. Now, so from when you calculate this elastic moment, that is why I took this. So you are calculating the elastic moment. You know how it is calculated. The ultimate moment of resistance provided at any section of a member is not less than 70% of the moment at that section obtained from the elastic maximum bending moment diagram, covering all appropriate combinations. So when you are designing any beam, okay, if it is a simply supported beam, you have only span moment. So simply supported moment, what is the support moment? That you can tell me at least. Simply supported beam, what is the support moment? Come on, at least that you should tell me. Come on. Khadija, are you there? Please unmute. What is the supporting moment of simply supported beam? Support moment. Khadija, are you there? Please unmute. Somebody is leaving because I'm asking questions. Khadija, are you there? Or sleeping? Please unmute. Okay. Haripriya. Haripriya, are you there? Steffi, these people don't answer only.
Ma'am.
Hmm? It is Steffi, no?
Yeah. Yeah, ma'am.
Yeah. So at least Sajjana, you know what is a support moment? So I have to come back to you.
0. At
Zero.
support it is 0.
It's 0. So fixed support means there is some moment at the support. Okay. So when there is a moment at the support, the code allows for a redistribution of the moment. Okay. So this is what it is. I don't know. If anyone wants to know about this, you can ask me. Maybe after the class or after anything you can ask me. I don't want to explain it now because I know it is too much. Okay. So I right away go to the case study. This is a building failure which happened way back only. Okay. So it is a Skyline Plaza apartment building. The background was it included 6 office buildings, 8 apartment buildings, shops, and 1 hotel. So $200 million residential commercial complex. It was $200 million. The design drawings of the collapsed building included the construction of 26 stories, a penthouse, and a 4-story storm basement for parking. The building design was of a reinforced concrete flat plate with a 200 thick concrete slab. Okay, it was a flat plate. The height between each story was 2.7 meter because most of the building was residential. During construction, none of the apartment building under construction collapsed. In that collapse, 15 laborers were killed and 40 were injured. This is the background. The findings were the collapse began on the 23rd floor when the slab of the 24th floor was being cast. On the 23rd floor, the slab started showing cracks. Okay. At that time, the 24th floor was being cast. The failure of the building occurred vertically along the full height of the building, including the basement levels. It was like a pack of cards. The adjacent post-tension reinforced concrete car parking structure also was collapsed. The analysis results showed the concrete had not acquired sufficient strength to carry the construction load supplied during the construction process. So 23rd floor that flat plate, it did not acquire the required strength. They were casting the 24th floor. So there was not enough strength for that floor. It was confirmed that the original design plan had no deficiencies. So design was pakka. The most probable reason for the collapse of the building was the punching shear failure on the 23rd floor of the building. You might have heard of punching shear. So this is one classic example of the punching shear failure. The collapse of the building was directly related to poorly managed construction process. So the court found that the contractor and the site engineer were guilty of negligence. The contractor didn't follow the building code requirement and the site engineer didn't inspect the work properly. So the violations of the prerequisites to completely shore the two stories underneath the floor being cast was very important. Failure to permit legitimate curing time before removing shoring. So they removed the shuttering before the curing time. Failure to conduct strength test on the concrete specimen in the field. This is also very important. That is why we always say, Steffi also know that in our site also we insist that whenever we are doing the concrete, from that batch, there should be a cube cast and the strength to be found. 7-day and 28-day strength. It is very important. Use of out of plumb shoring. This was also another reason. Improper inspection, that is to check the strength of concrete during casting and formwork removal. It is also not done. If you have a doubt, you can always have the NDT test done. So this should be done if you have any doubt. Okay, don't just keep things in your mind. Talk openly, tell people this is to be done. That confidence you should have. Now, improper installation of the climbing crane, that also was not done properly. Now, because of this, there was a lot of changes happened. A series of changes were made in the building code related to the progressive collapse of failure. See, this one flat plate, that is the concrete floor, flat plate, failed because of the punching shear, and that the whole failure was progressive because of that one failure. So special inspection procedures were added in the inspection section of the building codes, and design criteria were also changed for effective planning to reduce the possibility of failure due to progressive collapse. Which was very, very important, and which is very, very important, this progressive collapse. Even in our code also, there is a clause giving this progressive failure. See, this is the thing which is given in IS 875 part 2. Please see that 3.3, which is in the forward itself, it is given that you have to, even though the code is not saying that you have to do, the clauses are not there, but it is our responsibility to detail the different elements in a building so that progressive failure is prevented. Very important. Okay. So as a conclusion, I would say that codes provide detailed requirements, specifications, and guidelines. Codes also ensure minimum standard of quality, safety, and performance. Codes help to eliminate the problems of variations in quality and safety, and the interpretation of the clauses given in codes should be correctly done. Okay. Follow code, interpret the clauses in codes appropriately, discuss with seniors and peers in case of doubts. Remember, no code can eliminate mistakes and risks. Most importantly, use your engineering judgment always. Okay, thank you. So if you have any doubts,
Thank you, ma'am.
yeah, thank you.
Anyone have any doubt regarding the session?
You have any doubts, you can ask. If you want any clarification, please come back. You can message in the group. I would like to clarify those points. This is only an insight into the codes and the different clauses, how to interpret it. Okay. I want to introduce this to you, that there are things like this in civil engineering. Okay, they don't have any doubts, Steffi.
Okay, ma'am, we will wind up the session.
Thank you.
Thank you, ma'am.
Thank you all. Thank you, Steffi.
Thank you, ma'am.
Thank you, Sachin. Thank you all.